Assalamu alaikum students. Welcome to the channel The Physics Gurus. Today we are going to talk about the kinetic model theory from the particulate nature of matter. My name is Mrs. Ghazala Arif. I am MS Chemistry with 20 years of experience. The lesson objectives which we are going to cover today are explain the interconversion of the three states of matter in terms of the kinetic particle theory, and explain the energy changes involved in the changes of states. These energy changes we are going to explain with the help of the kinetic particle theory. These are the main postulates of the kinetic model of the matter. It states that all states are made up of very small particles, tiny particles. For example, atoms, molecules, ions, etc. The second postulate is the particles are in constant random motion. The particles are moving all the time. Now, if the temperature increases, higher the temperature, higher will be the average kinetic energy of the particles. So we can see that in case of solids, liquids and gases, what's going to happen? The average kinetic energy in case of gases is the highest, so does the average energy and so does the temperature. Now let's talk about the freedom of movement and arrangement of the particles that is different for the three states of matter. How this happens? When we talk about, first of all, when we talk about the movement, so we can see that in case of solids, the movement is in the form of vibrations. The particles are just going to vibrate at their mean positions and they cannot leave their place because of the close packing. In case of liquids, the movement is sliding. The layers of particles slide past each other because of the weak intermolecular forces. The layers slide past each other. When we talk about the gases, the movement is random. The particles are moving in all the directions with their maximum energy. So what can we talk about it? The movement in case of gases is random. When we talk about the arrangement of the particles, in the three states of matter, we come to know that in case of solids, the arrangement is highly ordered because the molecules or the atoms or the particles are closely packed with weak or negligible spaces between them. So arrangement is highly ordered. They have negligible spaces and strong intermolecular forces. In case of liquids, the arrangement is, they are closely packed and in case of gases, the arrangement is highly disordered, or we say random arrangement, because of negligible intermolecular forces and huge spaces between the particles. So in this case, in this way, we must be able to describe the movement and arrangement of particles in the three states of matter, and we must know that the freedom of movement and arrangement of the particles is different for the three states of matter. Now, the next point is the pressure of the gas is produced by particles of the gas hitting the walls of the container. Now, we can define the pressure as force per unit area. The force applied by the particles per unit area. Now, this force depends upon the energy of the particles the average kinetic energy of the particles, higher the average kinetic energy or the temperature, okay, higher will be the pressure, because higher will be the force applied per unit area. And secondly, it depends upon the number of particles present per unit area. So if there are more number of particles, then the pressure will be greater. Okay, number of particles per unit area. So the pressure of the gas is produced by particles of a gas hitting the walls of the container. The more often the particles of a gas collide with the wall, higher will be the pressure of the gas. So if this is the wall of the container and these are the particles of the gas, they are going to collide with the wall and they are going to exert pressure on it. Okay, so we have to learn these four main postulates of the kinetic model theory in order to explain the four states of matter and their interconversion. Now we are going to describe the microscopic organization of particles in solids. As we can see in solids, like this is a tin, so a tin can, and we can see how the particles are arranged. They are closely packed together and they have a regular arrangement in the form of the lattice. They cannot move freely because of the strong intermolecular forces and negligible spaces between them. Okay, so they keep on vibrating about their mean positions. It seems like they are not moving, but they are actually vibrating at their mean positions. They are in like constant motion. Now, when we are going to apply heat to the solid, what will happen? The energy of the particles will increase, okay, and the solid will start expanding. The solid will start expanding. Further increasing the heat energy, what is going to happen? The molecules will start vibrating with more energy and they will able to overcome the intermolecular forces between them. Okay, in this case they will start changing into liquid at their melting point. Now when we talk about the liquids, at that time we can see in liquids like mercury in thermometer, the particles in a liquid are closely packed together, irregular arrangement. They are able to move around, move past each other. Okay, they are able to slide past each other because the extent of intermolecular forces is weaker as compared to the solids. Now if we are going to heat this liquid, first of all what will happen? That the highly energetic molecules will be escaping from the surface in the form of vapors. This process is called as vaporization or evaporation. We are going to heat the liquid further until it will reach its boiling point. At the boiling point, what is going to happen? All of the molecules will gain enough energy to break the intermolecular forces and move apart. Okay, and this motion, this sliding motion is going to change to random motion and the liquid will turn into gas. This is called as boiling. Now let's talk about the next state of matter, that is gas. So for example, the argon gas bulb in the light bulb, the particles in the gas are arranged totally irregularly and they spread very far apart. Why? Because of the negligible intermolecular forces and huge spaces between the particles, and they are able to move randomly. Okay, so gas can be cooled down to form the liquid, and in the same way as we have explained the melting and boiling, we are going to talk about the condensation and then about the solidification or freezing. Like what happened when you are going to cool the gas, the particles are going to come close together, okay, and they will develop the intermolecular forces and they will start converting into the liquid, which is called as the condensation. In the same way, when you are going to cool the liquid further, okay, by keeping it in refrigerator or at a very cold place, the particles are going to move further close together, okay, and they are going to develop much more stronger intermolecular forces, and the sliding motion will change to vibrations, and this is called as solidification. The reverse is also possible. So this is about how kinetic particle theory explains the changes in the states of matter. Hopefully you have enjoyed your lesson about the kinetic model theory and the changes of the states with the physics gurus. Keep looking at our more lessons on the physics gurus. Thank you so much.